Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see what's there in today's daily challenge of Leetcode. So we are given find the maximum sum of node values. So there exists an undirected tree with n nodes from 0 to n minus 1 numbered, and the values of those n nodes is given in an n index array. So n length array, and the ith value represents the node numbered I, and you are given an edges which represent edge of I represent there is an edge between ui to vi. Okay, so you in one operation what you can do is that choose any edge u and v connecting the nodes u and v, and you can do the nums of those, like the value at those you can just XOR the values by k. Okay, you can just XOR the values by k and return the maximum possible sum of values Alice can achieve by performing the operation any number of times. Okay, so it is given that it is a fully connected undirected tree. A tree is always connected to each other, and that's all. You need to find the maximum possible sum of values. So first you give it a try, because this is a quite easy problem, hard easy kind of problem. If you just observe the value, there is like very little code you need to write. So I will just tell you to just draw the tree and just try to think what are the operations actually doing, and then continue with the video. Okay, so let's try to see the approach. So suppose you have a tree. Now this is a known fact that every node of a tree is connected to every other. Let's say this has the value 4. Now this has the value 2. Let's say this has the value 6. This has the value 8 and maybe 11. This has maybe 13 or might be 9. Okay, so you have a tree kind of structure. You are given edges. Full information about the tree is completely given. What you can do, you can go to any node and XOR with k. So first of all, you can observe one thing is that if there is a number x, if you XOR with k and one time you perform the operation, now if you again perform the operation XOR with another k, it is nothing but x. It is a property of XOR. 2k mixed to form x. I hope you know this. Now you see, so only one number of times if you perform a XOR, that only makes sense, because even number of times if you perform XOR with k, it cancels out. Okay, so now what can you say from here? You have only two possible values of every node. It's either x or XOR k. Okay, you have only two possible values. Now what can you say by this? You can say that these are nothing but cards, where one number is written at the front and the another number is written at the back. So let's say 4 is written at the front, and this is a card where 4 is written at the front and in the back it is written 4 XOR k. Okay, similarly for all those. Now you need to see that how to flip those nodes. So suppose you have this node connected to this node, connected to this node, connected to this node. You, let's say you are flipping these two values. Okay, what will be left? You will have 1 XOR k, and here you will have 2 XOR k. Now you are flipping these two cards. Okay, so this card is effectively getting flipped two times. So it is, you can say that you have not flipped this at all. Okay, you can say that you have not flipped this second card at all, and you are flipping this 3 XOR k. Okay, you are flipping this 3 XOR k. So what did you understand by this? Again, if you flip these two, if you choose to flip these two, this will get cancelled similar due to similar reasons, and you will get 4 XOR k. So what you can observe that if there exists a linear path between any two nodes, so let there exist two nodes x and y. Let there exist two nodes x and y. Okay, so let's try to write it clearly. One thing you can easily do is that if there are two nodes x and y, and they are connected, which is already given in the question that it is a tree, so they must be connected, then you can flip both of them without disturbing the other nodes. You can easily get this. Okay, without disturbing the other nodes, you can flip both of them. Okay, so now you get it, right? Any two nodes, you tell me 2 or 4 or 1 or 3, you can flip both of them in one operation only. But like you are using multiple operation, but there is no limit to the number of operations. That is why this problem becomes really easy. So let's say you want to flip 4 and 13, you can easily do that. 4 and 4, 13s are. So what you can do essentially, so you see that whichever number is greater, 4 or 4s or k, you keep a count that whether by flipping you get greater, or currently you are getting a greater value. So and you count in all the rows by traversing the nums array. By traversing the nums array of from 0 to n minus 1, you can just keep a track of which value is greater by flipping or the current value. You count all those values, count those values which are greater by flipping. Okay, which are greater by flipping. So if 4 XOR k is greater, then you do count plus plus. If 4 is greater than 4 XOR k, then you don't need to do count plus plus. You are understanding, right? Let's say 8 XOR k is greater than 8, then you do count plus plus. If 8 is greater, you don't need to do count plus plus. So you are seeing that which of the cards you need to flip in order to get a how many of the cards are there, you need to flip in order to get an optimal value. Now if there are even number of such count, if count is even, then what you can do, you get the maximum value. Okay, you easily get the maximum value. Or if count is odd, what you can do, you select the card which have the minimum difference between the number x and x or k. That you want to do, right? Because you want to track which has the minimum difference between its flipping and not flipping. Okay, and you want to sacrifice that value only. That will give me the minimal value, right? That will give me the most optimal solution, that within the value x or x or k, the out of all the nodes, the value x or x or k, whichever is having the minimum value of this absolute difference, I will sacrifice that node and flip all other nodes. Okay, so yeah, you can see like you don't need the edges at all. You don't need the edges at all. If you know that they are connected to each other, you can always flip, and this becomes a really simple code. So let's try to code it out quickly. So I have the caps lock on. So quite simple. I just do n equals to nums dot size. Okay, and what all things I have? I have ll sum, a sum value which I initialize to 0. I also have a minimum difference. I told you that I will keep a track of the minimum difference and for sacrificing that value. So I will keep int max. Okay, and what else? Let's see. Let's try to do it first. We will iterate through the nodes. Okay, we'll keep a XOR value at first. Okay, so XOR value is nothing but nums of I, XOR of k, nums of I, XOR of k. Okay, now after getting this, what you can see, you can update the minimum difference at first. Minimum difference is nothing but minimum of minimum difference and an absolute value of XOR minus numSci. You can easily see that you get this absolute value. And then if XOR is greater than nums of I, it means that flipping flipped value is greater, what you do? You do count plus plus, and definitely you must store the optimal value sum plus equal to num psi, XOR, sum plus equal to XOR, because XOR value is greater. And if the nums value is greater, if it is the either case, then you simply do sum plus equal to nums of I. Okay, so now you keep a track, you have also keeping a track of count, so you need to initialize the count variable, right? We are keeping incrementing count here, so that's why. And what I need to do now, if count is even, all I need to do is return sum. Else if count is odd, so I don't need to write else also. If it's going here, it means count is odd definitely. Then what you return? Sum minus minimum difference. So this is the value which you are sacrificing, right? So you have the total sum by taking all the optimal value, but only one case you are having the suboptimal value. For that suboptimal value, you have a minimum difference. That minimum difference you are losing it if you are selecting one suboptimal value in case of an odd count. Okay, so that will be all, I guess. Let's try to run it. Yeah, so we do have the accepted. Let's try to submit it. So yeah, we do have the accepted thing. You can see I haven't used the edges at all, and I am not really using any extra array also. And anyways, the runtime is quite good. So yeah, that's all for this problem. This was definitely a hard easy kind of problem, but I hope your day is going to be really easy. Thank you so much.